Okay, here's that pesky ornamental garden problem we were working on. You were given a figure and given the measurements of the sides, and we're missing the part over here. We don't know how much that is, but we also know that this internal angle is 160 degrees. You're asked to find the perimeter of the figure, and they're given a hint that you have to calculate the radius. So that tells me we really have to concentrate on the circle for starters. To find the radius, we're going to have to create some triangles, and that means drawing some lines. So first, let's draw a line to form a segment in the circle. And that goes from where the circle meets the rectangle to where the circle meets the rectangle. And it's a chord formed by that internal measurement of 160 degrees. Next, we're going to draw a line that will bisect the entire figure. And it does that because it goes through the center of the circle. So it bisects this line and it bisects this line. Because it's a bisector, it cuts it in half. So what was 20 here is 10 and 10, and this is 10 and 10. We know that this line is parallel to this line. The green line and the purple line are also perpendicular to each other. That's a quality of a bisector. So I'm going to use that triangle. We're going to focus on this one. I've turned it around a little bit so that it's easier to see. Here's my bisector going through here's the center of the circle. And because it's a bisector, it formed two 90-degree angles. We were told originally that this angle up here, this full angle, was 160 degrees. So half of that would be 80 degrees. And using what we know about the sum of the angles of a triangle, we can find this one by just doing some subtraction. We discover that it's 10 degrees. So I know if I have a right triangle, I get to think about trigonometry. And in trigonometry, if I have the measure of an angle and the measure of a side, I can use SOHCAHTOA to find the missing side. So let's pick 10 degrees, its adjacent side, and the unknown hypotenuse. So first set it up as the cosine of 10 equals adjacent over hypotenuse. You know that. And then we're going to do some plugging in. The adjacent side was 10 units. I don't know what the hypotenuse is, so it's going to be x. Then I'm going to use my calculator to find out what the cosine of 10 is, and it's 0.98481. So I'm going to plug that in over here on the left. Then I'm just going to cross multiply. And then I'm going to isolate x by dividing both sides by 0.98481. And what I get in the end is 10.1542. So the radius of the original circle is 10.1542. So now that we know the radius of the circle, we can concentrate on finding the measure of the segment. First of all, though, we need to find the circumference of the whole circle. So we're going to use the circumference formula, which is circumference equals 2 pi r. So I'm going to plug in what I've discovered, which was the 10.1542. So that totals up using my calculator to 63.8 units. That's the whole thing. And what we're doing at this stage of the game is we're comparing parts to whole. So we care about part of the total degrees. We care about 160 out of 360. And we care about part of the total circumference, but we don't know what that is yet. So here, let's look down here. We're comparing part to whole. So 160 degrees out of 360 degrees. Compared to, I don't know, over 63.8, which is the total circumference. So I'm going to set it up just like this, cross multiplying. I'm going to isolate the variable by division, and I come out with 28.356 for the segment. So I'm almost done. Now it's time to figure out what the total perimeter is. And to do that, we're just going to add up all the parts. So side plus side plus side plus side. 35 and 35, 20 plus 28.356 gives us 118.356. So just to recap, we started out with setting up a triangle, finding out the measures, using some of the angles of a triangle to find the missing angle, and then we used trigonometry to find the missing side. Once we had the missing side, we were able to use that, because the missing side was also the radius, to find the circumference of the circle. And then we were able to use proportional math to find out the part of the circle we cared about. And then finally, we just totaled up all the pieces and found the perimeter of the ornamental garden. And that's it.